Okay, so you've probably gone over the metric staircase in pretty much every grade from like 7th grade on, at least. Okay, so this really is review for everybody, but it takes students and teachers, for that matter, a long time to really familiarize yourself with how this works. Okay, now the nice thing is here we can't just jump decimal points, can we? Okay, we got to do our unit canceling. This is harder. Okay, this is easier. Okay, we are just jumping powers of 10. All right, things we use it for, base units. Okay, length. All right, our base unit is the meter. Mass. Base unit is the gram. Okay, now in physics, okay, we use the kilogram for everything. So we will always be converting to kilograms, but it's not the base unit. Okay, the base unit is the gram. All right, we'll talk more about that. Okay, volume. What's the base unit for volume in the metric system? It's not the gallon. Liters. Okay, capital L is the abbreviation. Okay, then this can be used for all sorts of stuff like energy, which we have not studied yet in this class. You may have studied it in other classes. What's the unit for energy? Joules. Okay, capital J. We've got units of power. Okay, what's labeled on light bulbs? What do we measure power in? Nice. It's the watt, capital W. Okay, we've done this one, frequency. Okay, like when we were dealing with radio stations and light and all of that. Okay, we are in hertz, and you can change units on the staircase with frequency. Okay, and there's lots of other ones too. Shane, will you put that magnet in the door? There's all kinds of things you can apply to this metric scale. Okay, and so we're going to talk about how to apply this to lots of different things in this class. Okay, so the base is right here. And here's the part that's major review for you. We will probably do some new stuff on here today too. Okay, let's start with the small units. Okay, DCM. All right, that stands for deci, centi. Okay, and what's this one? Okay, we got to kind of pay attention. That one's milli. Okay, we got to pay attention here because I got lowercase m for length. That's meters. Okay, but sometimes little m means milli. All right, you'll get used to when it's milli and when it's meters. Okay, so we have to kind of pay attention to that. Here's what they mean. Deci means 1/10. Centi 100th. And milli is 1/1000. Okay, so example, if I have a milliliter, that means I have 1,000th of a liter. Okay, so what's a liter of water look like? Yeah, you guys have them on your desk. Okay, that hydro flask right there, that's a liter. Okay, some of you guys carry the big 1.5 liter hydro flasks. In the 90s, we didn't carry those. We carried what? Anyone? Pop quiz, 90s. Canteens. Like with the carpet on them? No, we carried Nalgene's. All right, some of you still have those. Those are a liter. Okay, our base unit if we're talking volume. All right, let's get even smaller. We skip a couple stairs. Those are unnamed. They still are decimal point jumps, but they're unnamed. Okay, this stands for micro. Okay, we can skip 2 more stairs. And we have nano. Okay, and we're feeling kind of extra today, so we're gonna keep going. These are unnamed stairs, lowercase p stands for pico. Okay, and all three of those are for really, really small amounts of things. Okay, so a micrometer. We'll put an example on there. You could have a microliter, you could have a microjoule, okay? A micrometer is a common one though for micro. That's, all right, biology fans, if you're looking under a microscope or something like that and measuring cells and viruses, bacteria, you might be talking in microns, which are micrometers. Okay, here's what it means. This is 1 times 10 to the negative 6. Okay, you notice I didn't use a fraction right there. Okay, the negative 6 is the fraction. It means 1 divided by 1 million. Okay, nano. 1 times 10 to the negative 9th, or a billionth of something. Okay, and this is a trillionth of something. 1 times 10 to the negative 12th. Okay, so let's talk grams. Let's say you had a picogram. All right, if you took 1 gram of maybe like water or something like that, and you divided it up into a trillion parts, and you took one of those trillion parts, you would have a picogram. Okay, really small stuff. All right, any questions on those really little units? Those might be kind of new. That might be the new part of today. Okay, let's talk about the bigger units. Deca, hecto, kilo. Deca means 10, hecto's 100, kilo's 1,000. Okay, now in the real world, all right, these are rare. Okay, I don't see those used very much. Okay, this one right here, I'm going to put a little star by it because we use it all the time. Okay, it's an important one to pay attention to. And we know that kilo means 1,000, kilograms, 1,000 grams. And we're going to be converting to that a lot. Okay, when we're in mass, we have to be in the kilogram. Okay, bigger units. We're going to skip 2 stairs. Those are unnamed. Capital M stands for mega. And mega means million. So 1 times 10 to the 6th. Okay, so if you had a megameter, it means you have 1 million meters. Skip another 2 stairs. They're unnamed. Capital G means 1 times 10 to the 9th, or a billion. Okay, G, capital G, what's that mean? You guys know this one. Giga. Okay. I'm going to add some stairs, bonus stairs. We're going to run out of room. Okay, these 2 are unnamed. This top stair right here, capital T for tera. And it's 1 times 10 to the 12th of something. Okay, gigatera. What's common storage? Bytes. Yep. Okay, so we can go over here. Bytes, spelled with a Y. Okay, we can even put that on the metric staircase. Okay, 90s pop quiz again. Let's go down and do number 12 right here. Okay, this is megabytes. All right, what's what was common in the 90s that we used megabytes for? What kind of cool stuff did we have instead of phones for our music? The Walkman. Yes, correct. Early 90s. But by the late 90s, what did we have? No, we didn't have phones yet. Come on. All right, they were starting. No iPods until early 2000s. No tablets. They're round. CDs. Okay, CDs are 800 megabytes of storage. Okay, now our phones are in gigs. Okay, we got like a 32 gig iPhone or whatever. That's actually getting kind of small now. Pretty soon they're all going to have a terabyte or a trillion bytes on them. Okay, back to the 90s. So let's say I want to convert this to bytes. Okay, here's the easiest way. All you do is copy the number. Okay, then you think about what mega means. It means times 10 to the 6th. And that's all you do. You just tack on the power like that. Okay? Now, your calculator will be fine if you plug that in to do an equation with it or something like that. Okay, is your math teacher going to be cool with that? Maybe not. All right, it will work. I give you full credit for writing that down. Technically, it's not in scientific notation till we write it like this. One number in front of the decimal point. Okay, but we don't really care. All right, that just makes maybe one of your math teachers happy. That's scientific notation. Makes it a little more pretty. Okay, cleans it up a little bit. Okay, let's do a simple one here. 38 millimeters, let's say we want to convert that to meters. Okay. What we're going to do is we're going to find out where we are on the staircase. We're right here. And we want to go up how many stairs? We want to go 3 stairs up. Okay. We're going to take our decimal point. We're going from a small unit to a big unit. So our number should get smaller, okay? 38 millimeters is about that big. Okay, we're going to units of meters, so we're going to move decimal left, 1, 2, 3. And we'll have 0.038. Okay, so I'm going to give you some time to work on the rest of these, and then I'll put the answers under the screen so you can check your work. Okay, so use these 2 methods of converting depending on what makes sense for the example, and try these out. You can compare them with your neighbors.